All right, so the first thing I wanted to do is to go over some of that homework from last time. There were a couple problems we didn't really get a chance to talk about, and I just want to be sure that you had solutions to all of those in your possession. So I think you're okay on page 246. Just finding those values, positive or negative. Always keep in mind that cosine is the oddball. On any inverse cosine formula, you're always going to get a positive angle regardless. The quadrant determines positive and negative. Um, for sine and tangent, again, you may get a positive angle, you may get a negative angle. So let me jump to number 63, the tangent of the inverse cosine of 3/4. And remember, inverse cosine takes me back to an angle. So this problem says there exists some angle whose cosine is 3/4. I want the tangent of that angle. So I'm going to draw me a triangle for that. Since this is positive, I'm going to draw it in a quadrant where cosine is positive, namely quadrant 1. And I'm going to label that, just like we've done in the past. Cosine is defined to be adjacent over hypotenuse. So I'll label that triangle accordingly. So the adjacent side is 3, and the hypotenuse is length 4. So to find the tangent, I of course need this opposite side, this y value. So let me pause and use Pythagorean theorem to find that. So I end up with 9 plus y squared equal to 16. Y squared then is equal to 7, making 17. And then y is a positive square root of 7. So again, here is theta, and I want the tangent of theta, which tangent by definition is opposite over adjacent. So it is square root of 7 over 3. Problem 65 asks us to find the cosine of the inverse tangent of negative 2. So again, if I'm interested in inverse tangent and it's negative, then I've got to put it in an appropriate quadrant where tangent is negative. So namely, in this case, quadrant 4. And then tangent is defined to be opposite over adjacent. So I'm going to label that triangle accordingly. So if this is theta, then the opposite is negative 2, and the adjacent is length 1. So then let me go through Pythagorean theorem once more. And it looks like r is going to be the square root of 5. So again, I want the cosine of that angle. So cosine is defined to be adjacent to hypotenuse, which is 1 over the square root of 5. And I'm going to rationalize that. Square root of 5 over 5. Then number 83 was a little bit more abstract. Number 83 asks us to find the sine of the inverse cosine of u. So I just want to represent this in terms of u, and I'll tell you why we even have a problem like this is this comes up in calculus and some of the formulas and things that we do in calculus. But again, I'm going to approach it the exact same way. Let me draw me a triangle, and we'll assume u is positive, and let me label that triangle so that adjacent over hypotenuse is u, in this case u over 1. So a quadrant 1 triangle, I want the adjacent to be u and the hypotenuse to be length 1. I need to find a way to represent this third side of the triangle. So once more, let me use my Pythagorean theorem, which is, in this case, u squared plus y squared equal to 1 squared, or trying to solve in terms of y. So I get an expression for y that is 1 minus u squared. And then to find just y by itself, I'm going to take the square root of both sides. Keep in mind, square root is not a linear operator. I can't give a square root to all of these pieces. It just is what it is. So square root of 1 minus u squared. And so now I can find the sine of that angle. Remember that ultimately I'm looking for the sine of an angle. And so the sine is opposite over hypotenuse. So my solution here is going to be 1 minus u squared over 1, or just 1 minus u squared for that solution. So again, it's a little bit more abstract, but that's okay. It works. The work is the exact same. And then the last one on that homework page was number 87. Which is the sine of the inverse secant of u over 2. So again, the same sort of thing. We'll draw me a triangle, and let's see, secant is the reciprocal of the cosine function. So if cosine is adjacent to hypotenuse, then secant is hypotenuse to adjacent. So I'll label that triangle accordingly. I want the hypotenuse to be 2 and the adjacent to be the hypotenuse to be u and the adjacent to be 2. So I need the sine of that angle, which means I need this opposite side. So once more, Pythagorean theorem. 2 squared plus y squared equal to u squared. Y squared is u squared minus 4 when I multiply all that out and solve for y. And then again, the square root of each side. Once more, I can't take the square root of u and the square root of 4 because it's one quantity and it's the square root of all of that. So that's my opposite side. So sine is opposite to adjacent. It's opposite to hypotenuse. And so I end up with this expression for that solution. So that's the homework on page 248. And then I want to look at just a couple on 265. Beginning with number 5, we have y is equal to 5 cosine of x. And again, you don't have to write out all of these steps every time, but let's just think about getting x by itself. That was the goal. So to begin with, I can divide both sides by 5. And then to get rid of the cosine function, I've got to take the inverse cosine of each side. This is the step you don't necessarily have to show me. But cosine and inverse cosine, they cancel each other out. And so I'm left with x is equal to the inverse cosine of y over 5 for that solution. Number 9 is the same thing. It's just got more pieces. Y is equal to 3 tangent of 2x. So several pieces there that we need to get rid of. So the first thing I'll do is to divide both sides by 3. I now need to get rid of the tangent function, so I can take the inverse tangent of each side. Bear with me, let me be sure this might. All right, take the inverse tangent of both sides. And again, you're not dividing by a tangent, but you're applying an inverse function. But again, they undo one another. And then I can divide both sides by 2. Probably the back of the book is going to do a 1/2. And I get that x is equal to 1/2 the inverse tangent of y over 3. And then you had a couple that were more interesting on the next page, page 266. Number 23. 23 says 4/3 inverse cosine of y over 4 equal to pi. So I'm trying to solve this and trying to solve for the unknown. The only unknown in this problem is the y. So again, let's kind of whittle it away. So if I get rid of 4/3 by multiplying both sides by 3/4, then I'm left with the inverse cosine of y over 4 is equal to 3 pi over 4. I need to get rid of the inverse cosine, and again, we usually have a cosine and take an inverse. Now I'm taking an inverse, so I want to take the cosine of both sides. So once more, cosine and inverse cosine, they undo each other. So I'm left with y over 4 is equal to the cosine of 3 pi over 4. And as always, that's a special angle. So 3 pi over 4 is exactly 135 degrees. 135 is quadrant 2. It has a reference angle of 45. And so the cosine of 45 is square root of 2 over 2. But in quadrant 2, it's negative. And then finally, to solve for y, I want to multiply both sides by a 4. So finally, y here is negative 2 on the square root of 2. And again, we didn't really talk about applying a cosine. We usually applied an inverse cosine, but nonetheless, they are inverses one of another, so the mathematics works out regardless. And then number 27, the arc sine of x is equal to the arc tangent of 3/4. So again, if I want to get rid of an arc sine, what I can do is to apply the sine to both sides. So sine and arc sine, they cancel each other out. So this problem is the sine of the arc tangent of 3/4. And that was on the last page. We've already done that kind of problem. So let's do a triangle. There exists some angle whose tangent is 3/4. I want the sine of that angle. So tangent is opposite over adjacent. If I do Pythagorean theorem, I get that the hypotenuse is length 5. Therefore, the sine of theta is opposite over hypotenuse 3/5. And the same thing is true on number 29. Again, the notation is a little different. So if I want to get rid of the inverse cosine, I can take the cosine of either side. So once more, there exists some angle whose sine is 3/5. I want the cosine of that angle. And I think my triangle up above will be the same triangle that I need here. Some angle has a sine of 3/5. I want the cosine, which is adjacent to hypotenuse. Looks like x here is 4/5. So maybe that helps you with some of your homework there. And then we'll also pick up next with the last section that we want to think about.